Welcome to all for today's session. In today's session, we are going to see about the filament winding in composite manufacturing. Filament winding is a specialized manufacturing process used in the fabrication of composite materials, particularly those that require high strength to weight ratios. It involves winding continuous fibers impregnated with a resin system over a rotating mandrel to form hollow structures. This process is widely used in industries such as aerospace, automotive, marine, energy, and chemical storage, primarily for making pressure vessels, pipes, tanks, and cylindrical or spherical components. Then, basic principle of filament winding, or actually, the basic filament winding principle is to wind continuous fibers soaked in a resin around a rotating mold that is called a mandrel in specific and programmable patterns. The fibers are tensioned as they are laid down, which ensures proper compaction and orientation. Once the winding is completed, the resin is cubed, that means it is hardened. Then the mantle is removed if not designed to be a part of the final component. The fiber orientation and the resin type play key roles in determining the mechanical properties of the final product. By adjusting the winding angle, fiber type, the resin content, the engineers can tailor the component to withstand the specific loads. Example, axial load, radial load, or hoop stresses, or radial stresses, those kind of thing. And what are the different types of winding techniques available? Generally, we are having wet winding, dry winding, and a toe prick winding, and we have other windings also. Especially for wet winding, the fibers are drawn through a resin bath where they are impregnated with the resin just before winding. It is a cost effective and widely used one, as well as it requires good resin control to avoid drips or excess resin buildup. Then you can go for the dry winding. It is generally otherwise called as pre-prug winding. It uses pre-impregnated fibers, which resin is already embedded in the fibers. Cleaner process with better resin control. It requires heating systems to cure pre-prug the materials during or after winding. In toe brick winding, a hybrid between wet and dry methods are available. It also uses fiber bundle, other is called pre-impregnated with resin for better automation. Then the process overview about filament winding manufacturing methods. Mandrel preparation is very important. Fiber feeding and tension control is important. Winding process is important. Then curing, mandrel removal, and other things like trimming, finishing, everything is to be looked on very carefully. And one by one, we can see the process review overview about it. The mandrel in mandrel preparation, the mandrel acts as the base form over which fibers are wound. It may be removable or reusable for production, or sacrificial, or left inside the final component. Mandrel surfaces are often coated with release agents to aid in demolding. In fiber feeding and tension control, fibers are pulled from reels or fiber spools and they are guided through a resin bath, or it's called a wet winding. It should be in proper tension. Okay, proper tension is applied to the fibers to ensure compaction and consistent layup. And winding process, a computer-controlled winding machine moves the fiber across the mandrel in a programmed pattern. Common winding patterns are hoop winding. That means about 90 degrees. Fibers wrapped circumferentially for internal pressure strength. Another is called a helical winding. It is about 45 degree, plus or minus 45 degree, other angles also. Fibers wrapped at angles for axial load bearing. Other one is called polar binding. It is suitable for spherical parts. The combination of patterns provides multi-directional strength. As well as curing, the resin impregnated pot. The resin impregnated pot is cured using room temperature curing, oven curing, autoclave curing. Curing solidifies the composite and locks the fiber in place. Then mandrel removal. After curing, the mandrel is removed. The mandrels are collapsible, inflatable, or dissolvable to simplify the removal. Finally, trimming and finishing. Excess material is trimmed here. Surface finishing may be applied depending on the application. Regarding the materials used for fibers and resins to be discussed next. For fibers, glass fibers are used, carbon fibers or amide fiber, natural fibers are used. Glass fibers are very economical, corrosion resistant, and widely used. With respect to the carbon fiber, it gives the high strength to weight ratio, but expensive, ideal for aerospace and defense sector also. Aramid fiber, example Kevlar fiber is a very important one. It gives the high toughness and impact resistance also. Finally, natural fibers. It's a user-friendly, eco-friendly for specialized applications. Resins. Here we are going to use epoxy resin, polyester resin, vinyl ester resin, phenolic or thermoplastic resins. Generally, epoxy resin gives a high strength, chemical resistance, dimensional stability. Polyester resins are cost effective but suitable for general purpose composites. Vinyl ester resins are better than polyester in chemical resistance. Finally, phenolic and thermoplastic resins, they are less common. They are used in only specialized applications only. Then we should know the advantages of the filament winding also. Filament winding, fiber, that means they are having high fiber volume fraction, can achieve up to 70% fiber content and leading to stronger and lighter parts. And also excellent strength characteristics. Directional strength can be tailored through fiber orientation. Automation possibility are available at low labor dependency when compared to the hand lab technique, as well as cost effective for large runs. That means the ideal mass production of cylindrical parts like pipes and tanks are uh, doing very much important role in filament winding. Reduced material waste also important advantage in filament winding. Finally, we have the what are the limitations of filament winding. We should know only the shape limitation. Initial investment is high. Tailoring, that means the tooling and the programming complexities are there, limited to certain fiber forms only. So that's all about filament winding in fabrication of composite materials. In this class, we have to wind up to this one. We will see in the next topic in the next session. Thank you, 100% here. Thank you.